Hi guys, let's solve today's Leetcode problem, which is problem number 1861, rotating the box. It's a medium problem. Let's read this out. You're given an m cross n matrix of characters box grid representing the side view of box. Each cell of the box is one of the following: a stone that is represented by hash, a stationary obstacle that is star, and an empty that is by dot. Okay, a box is rotated 90-degree clockwise, causing some of the stones to fall due to gravity. Each stone falls down until it lands on an obstacle, another stone, or the bottom of the box. Okay, gravity does not affect the obstacle positions, and the inertia from the box's rotation does not affect the stone's horizontal position. Okay, it guaranteed that each stone in box grid rest on an obstacle, another stone, or the bottom of the box. Written n cross m grid representing the box after the rotation as described above. Okay, so as part of this problem, we are going to cover the two approaches. One is brute force and optimal. And now let's see the example. So if you see this example, this is the box that is given to us, and it is saying that we have to move this box to 90-degree. Okay, so after 90-degree, this box looks like something like this. Okay, so if I write it in two steps, it's saying that we have to apply the box rotation. So rotation, right after rotation, box will look something like this. So this is the stone, this is the stone, this is empty place. Okay, now this is just 90-degree rotation. Okay, then it also says that it applies the gravity effect. Okay, so the gravity effect, if we apply, so then this stone will fall down. Okay, so it will, how down it will fall, so until it hits the obstacle, or there is any sorry, it hits the bottom any obstacle or at top of any stone. Okay, so in case if you see there is another stone, so it stopped till here only. Okay, so these are the two effects. Now if you see the next example, so here also same thing would happen. In first this the rotation, this stone would be here, not here. Okay, now after the gravity effective will be applied, that stone will fall from here to here. Okay, and how will that happen? Because you see there is a obstacle. Okay, so it cannot go after I mean it cannot go after the obstacle, so it can, the max that it can go is still here only. Okay, so yeah, this is the problem that we are going to solve. Let's see what we can do. So brute force approach is simply what is being asked, we will do that. Okay, as I said, this is two-step thing. One is rotate and then apply the gravity. Okay, so normally rotating the matrix is a two-step process, taking the transpose and reverse. I will attach the other problem links which is similar to this in the description below. You can solve that to understand more about this. Okay, and there is the rotate image lead code problem which I have solved in my previous videos. You can go and watch that also. So rotation will happen, basically we'll apply the transpose and then reverse. This will rotate our given box into 90-degree, and then we will apply the gravity effect. Okay, so I'll just show you how this happens is, let's say we have given this box something like this. Okay, so here let's say there is a stone, and here let's say there is a obstacle. Okay, and then here there is one more stone. Now as we said, we have to apply the transpose. So this is a 3 cross 2 matrix. Okay, there are 3 rows and 2 columns. After transpose, what transpose does is it basically changes all the transpose, yeah, so it changes all the rows into columns and columns into rows. So this is one row that will be converted into column, so this will come as first column, this will come as second column, this will come as third column, which the third row as the third column. Okay, so how was this? 0 and nothing, nothing and 0, and then obstacle, and then nothing. Okay, so this is how it is. If you see the first column here, it is the first row, so that is what a transpose does. So this is, we have done the transpose, but we also need to do the reverse, because if we just see, if we have to change this, grid 90-degree rotation, so after 90-degree it would look something like this. This is how the this grid looks like. But here after doing transpose, this is something which is reverse of what we want. So for that reason we need to do the reverse also. So after doing reverse, you see this okay, so after doing reverse, this is how it looks like. Now if you see these two matches, okay, so this was reverse. And this 90-degree rotation is two-step process. One is transpose and then second is reverse. Okay. So this is how we are able to achieve the 90-degree rotation. Okay, let's dry run. How are we going to solve this using the two-step process that I told? So what we will do is we will do apply this 90-degree effect. Okay, so I will just quickly write that out for an ease. Yeah, so this in this example, if you see, if we apply the transpose, so this is how the transpose would look like. So basically this row first will come as this column, and similarly the next row as the next column, and so on. Okay, so this is after the transpose, and if you see the reverse of this, if we do, so this is how the each row reverse would look like. Okay, so this is after the reverse, and if you do the 90-degree rotation for this box, so this is the 90-degree rotation. Okay. Yeah, now we have to apply the gravity. Okay, so in this, now let's apply the gravity. So applying gravity is nothing but, if you see that there is one of this is our J pointer. Basically, we will apply this all the gravity. Uh, column by column. So first column, if we apply the gravity, so we can keep one pointer somewhere over here, and we can find the next value, which is a stone. Basically this is empty cell, right? So what is the next value if it is a stone? Okay, so we find this is the value which was a stone. So we put this stone over here. Okay, we will empty this cell, and then we can move this our pointer as next empty value here, and now we will again start from here. Okay, so we see this is empty cell, we see this is a stone. So what we can do, we can clear this empty cell and we can put a stone over here. Okay, now after this, we can move our empty cell pointer over here, and then we can start from the next cell, finding the next stone. And here we see this is the next stone. Here again we see I mean, this is was empty. Okay, this was again empty, and this is again empty. So at the end we were able to find place these this was empty. Okay, there was nothing. So this is one stone and this is another stone. We were able to apply gravity for this. But what we actually did is that we kept this J pointer. That is, I mean, basically we will apply this logic for all of these columns. Okay, and every time what we are doing, we are placing this position empty cell, and then for every remaining places, we are going this direction and finding the next available stone. Okay, and then we are swapping these values. But if you notice one thing, that we don't really need to go and find every time. Okay, so when I am here, I know that I have to swap some values, and I swapped till, let's say, I've swapped some value from here. Okay, so for why I am swapping some value from here, which means in between there is empty cells. That is why I have to go till here and then swap the value. And if I swap the value, which means that this will contain my new stone and this will be empty again. Okay, so since I know that this was already empty, this is again empty, and this is the next empty place. So the next values that I'm going to find is definitely from the remaining half. Okay, this is already empty. I don't need to traverse again on these one. Okay, so simply I can use two pointer over here, and I can optimize this a little. Okay, so and also we need to dry run on the obstacle case. So I'll do for this uh, end row, if okay, so end column. Okay, so here let's say our J is here. Now placed my last empty cell over here, but I see that this is not a empty cell. Okay, this has already some value, obstacle. I mean, this is not empty, this has obstacle. So in this case I will move my pointer to next. Okay, now here if I see this is empty cell, now for this one I will start finding my next stone. Okay, so I when I came here, I see this there is another obstacle, which means that whatever I have so far, since there is obstacle, there is nothing that can come after that. Okay, I mean, and a stone cannot pass this obstacle, right? So for that reason, this next empty cell, I will move this one to the next above the cell. Okay, so this is where my next empty cell will point. And I can start again my pointer to start from here. I will find the next stone, and I found it, so then I will swap these two values. Okay, so after swapping I can move this pointer ahead. So this is what I'm going to do all together, that for every column I am going to check if I will basically point my last empty uh, you know row as this last value, considering this would be my last empty value. If not, then we will move this. Okay, but I will consider that this is my last empty value, empty row, and every time we will move our j pointer here, checking, okay, if this is my last value or not. And if I have found any of these as the stone, in this case if you see we found this stone, so we will just swap the values. Okay, and we will move this next pointer to above. Okay, we will basically reduce this value j. Okay, sorry, I. So yeah, that is what we are going to do, and I hope that's clear. I can now just write the code for this. So as already mentioned that uh, doing the transpose thing, this cannot be done in I mean, finding a transpose of matrix cannot be done in place. Okay, we need to have another matrix. So in case if it would have been a square matrix, okay, so n cross n, then doing the transpose can be done in place, because there we just do the rotation. Okay, so rotation, sorry, my bad, not rotation, there basically we can swap these values. Okay, so these value, if I swap with this, then and this value with this, and similarly this value with this. So after doing this swapping, we will be able to achieve our transposed matrix. This works because it is n cross n matrix. This works. Okay, and we can achieve in the same swapping in the same matrix. But in case of n cross m matrix, which is n and m are different, so that is swapping itself is not possible. So for that reason we need to have another metrics to store the transpose. Okay, and here if you see, so if we just do transpose for this, so definitely it is something of, let's say, 1 2 3 4 4 cross 2, right? So this will be 2 cross 4, so this swapping itself fails here, right? So yeah, that's for that reason we need to do this. And we so that's why we will need that. Okay, now I can store this n as number of rows. Okay, so that would be nothing but box that we have dot size. Okay, and m would be box of 0 dot size. Okay, now I will initialize answer box array, so that would be storing this character answer. And as I mentioned, right, after transpose, basically doing this 90-degree rotation, one was doing transpose and another was doing reverse. And we know that after doing, anyway, this is the matrix, and if we do 90-degree rotation, it will look something like this, and vice versa, right? Yeah, so something like this. So which means n cross m becomes m cross n. So here if you see, n was the row, m was the column. But this, the new one that we are going to build, so there m will be the row, and this n will be the column. Okay, and initially I will initialize all of this with empty values. Okay, so I'll point that as dot. Yeah, so this is what it is. Now I will do the transpose. So transpose in this case, here we were just swapping this values, but in, I mean, in the same matrix, in case of n cross m, n only, but in case of this we can just swap the values. So swapping the values would be, I mean, not exactly swapping. So here if you see, whatever the value it is here, that goes here, right? Which means there was I comma j, that got changed to j comma I. Okay, for doing transpose. So same thing we will do. We will iterate over our existing array, existing box. So I is equal to 0, I less than n, and another loop will be j is equal to 0 and j less than m. And here, whatever our answer of ji will store is something of what box of ij stores. Okay, so after this, the transpose would be done. Now we can reverse all of this. So it would be for I is equal to 0, I less than n, and then reverse answer of I dot begin. So sorry, this will not be n, this will be m, because we have to reverse all the row, right, after the transpose, right? And we know that earlier it was n cross m, now it is m cross n. So rows, number of rows are now m, so that is why we will do it m. Begin comma answer of I dot end. Okay, so yeah, now we have reversed it. Step 1 is done, where we have rotated this 90 degree. Okay, 90-degree rotation is done, where the first step was transpose and the second was reversing. Okay, now next is applying the gravity. So we know that for applying the gravity we do this for each column. So our column goes from j is equal to 0 till j less than n. Okay, n, why n? Because we have swapped the this, right? After rotation, this n cross m becomes m cross n, right? So for that reason, this is now number of columns are n. Okay, so yeah, we will apply this gravity effect in all of these columns one by one. Okay, so yeah, one more thing just to mention, that applying the gravity effect does not changes something like this, that if you see the output, it's not like there is empty cell, it will go sideways also. So it is just our apply gravity will apply in each of these values only. I mean each of this row it will go like this. Okay, eventually, which means if you see this one, so this is the each column, so gravity will happen just downwards. Okay, if you see this one, gravity will just come downwards, so this cell will come downwards, not like that, now 0 comes here, there is this empty cell, it will move here, not like this. Okay, so this gravity applies only column by column. So yeah, each column we will apply the gravity. Now as I mentioned that we keep the this end value as last row with empty cell. Okay, so we will store this value, and we can initially store this as m minus 1, because there will be m rows, as we see this is m rows. So last row will be, we will consider that this is our last empty cell. Okay, if not, then we will figure it out. Okay, now from there we will start our movement in the uh, above direction. Okay, so there is where our eye will move, that will start from the last row and it will go above. Okay, so eye is, it will move nothing from but I will move from m minus 1, I greater than equal to 0, and then I minus minus. Okay, and here what we will check, if this answer of ij that we have after the 90-degree rotation, if this is a stone. Okay, so in that case what we can do is, first is we can mark that ij value as empty. Okay, because yeah, because let's say if I have something like this after rotation, and here there is already a stone is there. Okay, so when a stone is already there and I am considering that this is my last visited last empty cell, then in this case we know that first thing is that this will be here only. So first is we will make this as dot, and then we also know that we need to swap this value, this row basically that is our last row with empty cell, and this column as value hash. Okay, so I mean, this is to note that we should do it in the correct ordering. We should not break the ordering, because if we make this value, because if you see these all this I pointer and this last row empty cell, both are pointing to the same position. Okay, now if we did it first, basically if we made this value hash first and then we change it to dot. Okay, so eventually this value will be dot, right? Which means this is empty cell, but that is invalid since these both of them are pointing to the same. So what we will do, I mean, this is just to include the edge case handling of this case where both the pointers point to the same place. So what we will do, we will just point whatever the j is nothing but the place where we have found our stone. We will mark that as dot, that empty cell, and where is our last empty cell, we will mark that as stone. Okay, because that is how the gravity effect will apply. And else if this is not a stone, this is a obstacle, so we know in case of obstacle we need to reset it. Okay, so answer of ij, if that is equal to obstacle. Okay, obstacle is star, it's denoted by star. So if that is the case, then last row with empty cell will be we need to decrease this value basically. So whatever, wherever it is pointing, we know that now since we have found the stone, let's say sorry, obstacle we have found, right? So wherever it might be pointing, somewhere here or wherever, we know that now any stone after which is before this stone, obstacle, it cannot go after this. Okay, so that is why this empty cell doesn't make any value, so we will move our empty cell here. Okay, so yeah, empty cell would be nothing but I minus 1. And yeah, this is after this we it is done, and then at the end we can return the answer. So yeah, this is how it will be done. And if we discuss the space and time complexity for this approach, so one, this loop is running of n into m times to build this transpose matrix. Then we are reversing, each reverse will take of n time, and then we are doing this m times, so n into m here also. And if you see this one, so this is n times, and inside we are moving this m times. So O of m into n, three times we are doing. Okay, so m into n, that is our time complexity. And space complexity, since we know that for doing the rotation, we need to do the transpose, and for transpose we cannot do that in place. Okay, we need this additional matrix for storing the transpose. For that reason we needed this as another additional space. So space complexity is O of m into n. Okay, so yeah, that's about this time and space complexity for this approach. Now let's discuss the optimal approach for this problem. So, in above, what we were doing is we were calculating this transpose reverse, and then we were applying the gravity effect. But let's think if we can apply all three of them in a single place. Okay, basically doing in all of this in the single iteration. Yeah, one thing we know that I mean, if we have to just if we this is our ij, and if we do the transpose of it, we know that it swaps these values. Okay, I becomes j, j becomes I. Basically all the rows become column, column becomes row. So this is what happens to the index if we do the transpose. Now when we do the reverse, this is what it becomes, that j and I minus. I'll explain you how this reverse one works. Okay, so let's say there is some value 1 2 5 6 7, okay, 8. Now these are the indexes. Now if I apply the reverse over here, so this is after reverse how it will look like 8 7 5 something something 1. Okay, now if we check for this value, let's say 7, so 7 was initially at this value 4, right? But here in this case it is at 1. So after reverse, what happens to this index? So here I was at 4, this was the length was 6, but in this case it is pointing at 1 after reverse. Okay, so we can say that our length was 6. Okay, and this is 4, so 6 minus 1 if we do, because this is the total index if you see, is from 0 to 5. So 6 minus 1 will give us 5. Minus if we do 4, this will give our value 1, which is nothing but 6 minus 1 is nothing but n minus 1 minus this is our current I, and this will give us 1. So this is how the I changes. Okay. Whenever we do the reverse, this is how this index changes for this value. So 7 will initially had this index 4. After reverse it became index, it came at index 1. Okay. And same will happen with otherwise also. Okay, other cases also. So this is our j remains same after reverse, because we are doing row wise reverse. Okay. So when this was our box, so we did this reverse of this, I remains same. Okay, this is not changing. So what is changing here? J is changing. Earlier it was something like this, let's say. So it was 0 1 2. Now it became 2 0 and 1, 2 1 and 0. Okay, so this J value is changing. Okay, indexes of J are getting changed. I is same. Whatever this was initially at first row, again it is at first row only. So, and in this case, after rotation, we know that I is nothing but J. And what is the J? J was I. Okay. But we know that after reverse, this is how it will look like. So yeah, after rotation, this is our new index, which we know. So we know that new index will be J and n minus 1, comma, minus I. Sorry. Yeah. This is what our new index will be there. Now, the intuition is that we what we can do is we can traverse in this box row by row. Okay, we will traverse row by row, and we will simulate the gravity effect. Okay, so what is the gravity effect? That here if you see, we can have the similar to above, we can have the last empty column cell. Okay, so last empty column cell would be the last position over here. Okay, and then what we can do is we can move our pointer from the here m minus 1, and here this is our j. Okay, and this is our last empty column. Okay, from here, and we can keep on moving like we did for our columns. We can do that for row, and same way we will accordingly move this 0 over here. Okay, now uh, this is where we know that this 0 need to be moved here. Okay, so this was our initial position of the stone, and we know that this will be our next position of the stone. Now in simple case we would have done that. Okay, where we need to apply, let's say, gravity rightwards, we could have done that, but we are thinking to do this in single iteration. So we traverse the row and we simulated the gravity effect, which means we knew that this is the place where this stone need to be this stone need to be uh, swapped with this empty value. Okay, so we got to know that, but instead of placing this value here directly, we would place that in the rotated position. Okay, so what would be the rotated position for this one? We know that our ij was something like this, and after this 90-degree rotation, this is what the rotated position is, like this. Okay, so that is how it is. I comma j, we will place this one here. Okay, now if we see, so here we got to know that initially 0 1 2 like this. Okay, so for this 0, which was initially 0 0, we know that the position to which it should be rotated with is 0 comma 1. So this is the new position where we have to place our stone. So I for this rotated index will be j. So j is here 1, so it is 1 comma I. Okay, so for I we know that it is n minus 1. So what is the n value? So n is 3 minus what is 1 minus I. So I is 0. Okay, so this is nothing but 2. Okay, so eventually if you see, this is nothing but 1 comma 2, and in the rotated position if you see 0 1 2 0 1, so this place is nothing but 1 comma 2. Okay, So yeah, this is how we are going to do it, that this is our new position and we are going to place our empty cell like that. So we just traversed in every row, and we found the new position for each of the stones like we did above using the two pointer. And instead of swapping with the new position, we swapped the value with the rotated position. So this was about the stone, okay, that we need to rotate. But if that is not a stone, that is a obstacle, okay. So in case of obstacle, we know that we just need to swap the values, okay. uh, we don't need to swap with the last empty cell. Obstacle also, we know that this will be after rotation, this will be pointing at some position, okay. So this will again apply, this index value will still apply, but here in case of this we were just using our last empty cell, but here we will directly apply, okay. So yeah, this is how we are going to do it. Now let's write the code for this. So same thing, n will be our box dot size and m will be our box of 0 dot size, okay. And we will have this answer array. So vector of char of answer, which will be again of size m, comma vector of char of n comma empty, okay. We will initialize this with empty value. Now here what we need to do, so we will apply this gravity effect row by row first. So it will start from 0th row and it will go till n I plus plus, and here we need to keep the last empty column cell. So last empty column cell, that will point to m minus 1, okay, because that is our uh, now the number of rows are m, right? As I mentioned, it was initially n cross m. Now after rotation it became m cross n, which means there are m rows. So last empty column is nothing but m minus 1. That is after rotation, right? But here we know that we are applying this in the every column, okay, sorry, every row. So yeah, now what we will do, we will keep moving our j pointer from m minus 1, j greater than equal to 0, j minus minus, and if the box has this ij value as a stone, then we need to swap that with the last empty cell, okay. So last empty cell, whatever it is, and we know that this is the row value, okay. We find this last empty cell in the new position, okay. So I mean it would have been the new column, right? Here we are moving the column, so we know the column position for this. So here we knew that this was the column for which I need to swap. Let's say this was our last empty cell and there is our stone. We need to swap with this value. But since we found that this need to be swapped with this, but we are applying this rotation effect. I mean this implication we are doing in the rotated matrix. For that reason, we know that I comma j got swapped to j comma I and all that. And after that, this j is what it is. So here we found this j, that is last empty cell. And what is this I? So I was nothing but n minus 1 minus I, right? So that becomes our j value for the rotated one. So same we will do. That would be n minus 1 minus I, and here we will assign this value hash to it, that is a stone. And after this we will move our last empty column to minus minus we can do, okay. Else if this box of I j is a obstacle. Okay, so if this is an obstacle, then we can simply move this value, yeah, j and n minus 1 minus I to star. Okay, and then last empty column, we will move this to j minus 1, because we know that if there is a obstacle, no stone can fall after that. So our we need to move our j value also. Okay, if that is a, I mean, we need to move our last empty cell to the latest value. Okay, and this was the case where we just found our stone, so we need to just move to the one position ahead. Okay, so yeah, this is what it is, and at the end we can return answer. Okay, so yeah, time complexity wise it is same, and space complexity, if you see, so I mean space complexity is also same of m cross n only, but in case of time complexity, initially we were running three loops to achieve this. Three times we were iterating to achieve this, but in this updated approach, we just need to do this entire thing inside one a single iteration only. So yeah, that's all for this problem. I hope you like this video. Thank you for watching. Stay tuned for next videos.